All right, welcome back to this class. Let's consider metalloids. We have treated metals and non-metals before. We said metals are elements that ionize by losing electrons. They lose electrons to become positively charged. A good example is sodium and potassium, etc. Then on the other hand, non-metals are elements that ionize by gaining electrons. They gain electrons and become negatively charged. So a good example of a non-metal is chlorine and nitrogen. Now, from the word metalloid, metalloid is in between metal and non-metal. It means they are neither metal nor non-metal. What do I mean? They are neither non-metal distinctively or metals distinctively. So it means their properties lies between the property of metals and non-metal. What do I mean? It means their properties is intermediate between metals and non-metals. It means we cannot really call them metals and we can't really call them non-metals. So they share both the properties of metals and non-metals. At times they are called semi-metals because they have some of the properties of metals and slightly some of the properties of non-metals. Examples of such elements are boron, silicon, germanium, arsenic, etc. Let's consider a periodic table to show their location in the periodic table. They are always in diagonal manner in the part where we have the non-metals. Now consider the periodic table. Those elements that are painted, that are found in yellow box are metalloids. It means starting from boron, silicon, germanium, arsenic, antimony, and tellurium. Those are the metalloids that we have in the periodic table. If you consider the top, you can see that both boron and silicon are the only metalloids that we have among the first 20 elements, boron and silicon. So their location is in the block P. So they are found in the block P of the periodic table. And mind you, the properties of metalloids is intermediate between the properties of metals and non-metals. That's why they are called metalloid. At times, they conduct electricity, while some of them do not conduct electricity, while at times they don't conduct electricity. They don't conduct like metals, and they are not non-poor conductors as non-metals. So that's why they are called semiconductors of electricity. So we believe that with all of this, we have been able to treat metalloid in a simple way, and subsequently we'll be talking about them later.